In this problem, we want to determine the force in each member of the truss shown, where P1 is 800 newtons or pounds acting down, and P2 is 400 to the left. Okay, so what we do is we start at a joint where I have something known and no more than two unknowns, which would be point B, because I've got the two known forces and then just BA and BC acting up. So I draw that free body diagram shown here. Again, I have my external loads, 800 and 400, and then I have FBA, FBC, both here assumed to be in tension. Okay, at their specific angles. I got a 3, 4, 5 triangle and a 45-degree angle. So that's my free body diagram at B, assuming both of those members are in tension. So I sum the forces in the X, set them equal to 0. I get FBC cosine of 45 minus 3/5 FBA, and then minus 400. So I have those three forces acting horizontally. Vertically, I have FB sine 45, 4/5 of BA, and then a negative 800 going down. Solving both of those equations for my two unknowns, AB and BC, I find that they both give positive answers. So my assumption that they're in tension is correct, and I find that FAB is 286 and FBC is 808, both in tension. Okay, so now I have AB and BC. I move to another joint. I'm going to move up to joint C because I've only got one unknown reaction, CY there. So I don't forget that external load, CY, just like I had 800 and 400 at joint B. So I've got CY acting straight up. And then I know I have 808. That's FBC. I know it's in tension, so I draw it out from the joint. And then I have FAC, which I'm going to assume here is in compression. So I draw that in to the joint. Okay. Now, in order to find FAC or CA, I can just simply sum the forces in the X direction, where I have FCA acting in the positive, and then 808 cosine 45 acting in the negative X direction. CY is only in the Y direction, so I can basically ignore it, neglect it from the horizontal equation, and I get FCA equals 571 by solving this equation up here. So again, with joint analysis, you pick a point that has at least one known, at most two unknowns, apply your equilibrium equations there, figure out tension and compression, and then move on to another joint with no more than two unknowns and at least one known, and keep moving until you've solved each member in the truss as we've done here.